And now we come to section 3.3, decreasing at constant rate. And again, we have the same formula for calculating the amount. We have A equals to P times 1. Then this time it will be 1 minus R to the power N. And we call this factor 1 minus R as the decay factor. Decay factor. And this factor will always be less than 1 since R is a positive number. And in later parts of the textbook, this is also called the depreciation factor or depreciation rate. 貶值率. And the actual decrease in value, we call this depreciation, which is given by the formula P minus A, since this time P will be greater than A. And now let's look at example 7. The number of a certain kind of bird in danger of extinction is 1,500 last year, and the number found in this year is 1470. Find the percentage decrease. Therefore, we can simply apply the formula of calculating percentage change. And this will be 1500 minus 1470 divided by the original value, which is 1500, multiplied by 100%. And the answer is 2%. And now in part B, if this kind of bird continues to decrease at the same rate, that is, the number drop by 2% each year, what will be the number of this kind of birds 5 years later? And since this year we have 1470, therefore the number of birds 5 years later will be 1470 times 1 minus 2% to the power 5. And the answer is 1330, correct to the nearest 10. Okay, example number 8. A digital camera was bought 1 year ago, 1 year, and the depreciation rate is 20% every half year. So if we draw a timeline, this is now, this is half a year away, this is 1 year ago, and since it depreciates by 20% every half year, so in fact there will be 2 times of depreciation in 1 year. There are 2 times of 20% drop of the value of the camera. And if the present value of the camera is 1472, what is the original value of the camera? So we can simply let P be the original value, P dollar. And by observing this timeline, we have P times 1 minus 20% to the power 2 will be equal to $1472. Therefore, we can write an equation. We have P times 1 minus 20% to the power 2 equals to 1472. And this part, we can make use of our calculator to find out its value. And this will be 0.8 squared, which is 0.64. And therefore we can find the value of P by dividing 1472 by 0.64. And the answer is $2300. Therefore, the original price is $2,300. Well, let's look at one more example from the question number 13 of your textbook exercise. And Patrick bought a digital video recorder at $5,600 in 2004 in a year. And its value depreciates by 20% every 2 years. A part. Find the value of the digital video recorder in 2008. And to make the picture a bit more clear, we can simply draw a timeline to illustrate the story. And since we have 2004, the original value is $5,600, and it will depreciate by 20% each year. Sorry, every 2 years. And therefore, in 2008, there will be actually 2 times of depreciation of 20%. There will be 2 times. And now, if we are required to find the value of the recorder in 2008, we can again make use of the formula. P times 1 minus R, 20%. And since we have actually 2 times of 20% depreciation in 4 years, and this is a very important word, depreciate by 20% every 2 years. So there will be the power of 2 here. And our calculator gives us the answer, $3,584. And in part B, the questions changed a little bit. And if the value of the recorder depreciates by 10% every year, and then the story will be different. And if we again draw the timeline, there will be a total of how many times? 1, 2, 3, 4 times of depreciation from the year 2004 to 2008. 1, 2, 3, 4. So, the value in 2008 under the new situation will be 5,600 times 1 minus, and this will be 10% per year. And we have 4 times of depreciation. So the power will be the number 4. And our calculator gives us the answer, $3,674. And in fact, actually, the answer should be correct to nearest 10, but giving one more significant figures really doesn't matter. And actually, this number is greater than the answer in part A. And the question asks us, will this value be the same as that found in A? And therefore, the answer is no. The answer is not equal to part A. And in fact, it is a bit more, about $100 more than that in part A. And therefore, the difference will be $3,674 minus $3,584, which is $19. And actually, this is an increase in the value. Finally, we come to example 12. A cinema carried out renovation work at the end of 2007. When it reopened in 2008, all the ticket price were increased by 12%. And the number of audience, however, it dropped by 35%. What is the percentage change in the total income of the cinema from 2007 to 2008? And actually, we can see that the income of the company, of the cinema, actually comes from the sales of the cinema tickets. And this number will be the total number of audience times the price of the ticket. And this will be the income, total income of the cinema. But since this problem does not give us the number of audience in 2007 and the original price of the tickets in 2007, therefore we have to let the number of audience and the price of tickets be some kind of variable x and y. Therefore we let the number of audience be x and the ticket price be $y in 2007. Therefore, the original income will be x times y, and new income in 2008 will be x times, since x is the number of audience, and actually it dropped by 35%, there will be x times 1 minus 35% multiplied by y, followed by the factor 1 plus 12%, since the ticket price increased by 12%. So the answer is 0.728 times xy. So actually you can see that there is a drop in the income. And so the percentage change will be the new value, 0.728 xy minus the original value divided by the original value. And then finally multiply by 100%. So this will be minus 27.2%.